Okay, let me explain again about this example. So we are studying about the distance measure. We call it the DTW. This is the dynamic time warping. And we call it, this is signals. So signals can be anything. Maybe you can see the stock price, or we can see the demand, or anything which is the numerical value. So we have P and we have Q, and this is a sequence of time. Okay. The first is 1, and then 4, and then 5, and then 10, and then 9, 3, 2, 6, 8, and then 4. So we have also the same sequence, but we have different values. So we want to know the distance between P and Q. If we do the plotting, this is the plot. The blue is the series 1, and then the orange is the series 2. So when we are making the distance measure with the TW, first we will create the empty cost matrix. So this is the empty cost matrix. We have the P. The P is 1, 4, 5, 10, 9, and something. And Q is 1, 7, 3, 4, 1, and so on. So first is empty, nothing. And then we need to fill in the cost matrix using the formula starting from this left part. So I guess you already know this formula. Mij, I means the position of the P, and then J is the position of the Q, and we are going to use this formula. So for the M11, we know that the value of P1 is 1, and the value of Q1 is 1, then we got 0. Because 1 minus 1, we have the absolute, it is 0. And we want to find the minimum of I minus 1, then it is 0, comma J minus 1, this is 0. And then we have the M of 1, comma 0, and then we have the M 0, comma 1. M 0, comma 0, yeah, nothing. M 1, comma 0, nothing, just 0. M 0, comma 1, also nothing, it is 0. Then we can say that the minimum is 0. So 0 plus 0, it is 0. Next is 1, comma 2. We have the value of the P. Okay, maybe it should be 1 minus 7, but yeah, it is the same, 1 minus 7 or 7 minus 1, because you will do the absolute. Then the result is 6, and then we want to check the minimum. What is the minimum here? We have 3 options. We have M 0, comma 1, and then M 1, comma 1, and then M 0, comma 2. So for the M 0, comma 1, it is 0. For the M 0, comma 2, it is 0. And for M 1, comma 1, it is 0. Then we have 6 plus 0. The result is 6. So ends on, we know the 2, comma 1, which is here. We have the value 4 minus 1. Then it is 3, and we want to plus with the minimum M1, comma 1. Then the result is 3. So let's see if we have like this one. So we can calculate all, and let's see M3, 3. What is M3, 3 here? We need to subtract the value 5 minus 3. So it is 2. And then we need to check the minimum. We have M3, 3, then we need to check the minimum of 2, 2, M3, 2, and then we need to check the M2, 3. It means we need to check the surrounding. Okay? We need to check the M2, 2. We need to check M3, 2, and we need to check M2, 3. So the surrounding of this value will be checked. And we need to find the minimum. So what is the minimum of this one? 5, 3, and 4. We know the minimum is 3. Then the subtraction value, which is 2, will be added with 3. So the result is 5. So we need to fill in all the numbers. So we need to fill in all the cells in this matrix until it is full. Okay. You may have like this one, and then you will fill. Maybe it is easier to fill in with this direction, and then this is the full matrix. After we have this full matrix, or we can say this is the complete cost matrix. So we need to check the warping path identification. What does it mean by warping path identification? So we need to find which distance is the smallest. And we need to check from the top right. So we have 15. Okay, this is we will do from this number. And then we need to check the numbers which is the minimum in the surrounding of this number. So we have the number in this position. We need to check 18, 15, and 18. So what is the minimum? The minimum is 15. Then we will go to the next by selecting 15. And then after we select 15, again, we need to check what is the minimum, the surrounding of this 15. So we need to check the numbers from the top right until the left bottom. So we have the 15, and we need to check the surrounding again. 19, 15, 14. What is the minimum? 14. And we will go to 14. Again, we will check the minimum surrounding 14, which is 15, 13, 17. So what is the minimum? It is 13. Then we will have a value until the last one, which is the minimum is 0, which is the left part. So this is the final warping path identification. Okay, so if you check from this one, 15, and then we have 15. So the minimum surrounding is 14, and then we have the minimum is 13, 11, 9, 8, 8, 4, 4, 3, and 0. So we call this is the warping path series. And let's say I call this is the T. T represent the distance. And we can calculate the final distance calculation by do the summation for all these values, and then we will divide with k. K is the number that presented here. So for example, here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 numbers. So the k will be 12 in our case. So the big T or the final distance will be the summation of all numbers, so the gray color numbers, and then we will divide with 12. So the distance, the final distance calculation using the DTW will be this value, 8.6 feet. So we can say that there is a difference between the P and the Q, and the distance is 8.6 feet. Now we have another example. This is another time series. I have the series 1, which is 1, 1, 4, 10, 9, 3, 2, 6, 8, 4. And then I have another series, is 1, 4, 10, 9, 3, 2, 6, 8, 4, and 4. If you plot the series, it will be like this one. So you can see the pattern. It seems the pattern is similar, but it has a delay in one time. Then using the DTW, I think you already know the step. You can generate the empty costs. After you generate the empty costs, you can calculate for every of the cell. And after you calculate for every of the cell, you will get the complete cost matrix. After you have the complete cost matrix, you will start from the top right, and then you need to select the minimum until the left bottom. So the minimum here is 0, 0, 0, 0, 0 until this part is 0. Then we can measure the distance, the final distance calculation, by looking at every of these 0, 0, 0, 0, 0, 0 until the end, and then we will divide with the total number, which is 11. So 0 divided by any number, it will be 0. So we know that this series and this series, they have no distance. They are similar with the delay with time 1. So let's say this is the period. So there's a delay with time period, 1 time period. So this is common approach when we are dealing with the TTW. And of course, you can expand this TTW. Let's say I want to make only with 1. Then, okay, you can have with 1 time period. You can have with 2 time period. You can have with 3 time period. Of course, it will be more complex. But let's say this one, this is the basic TTW with one time here. Okay, that's about the time series. Actually, there are still many more things that we can learn, but let me just give you a brief explanation about the time series. Now, I would like to explain about another kind of data, which is the text data. Text data is also very uh, popular in the data mining, and we can uh, make some categories for the text data. How we can mine the text data? The mining text data, we can start from the structured data. The structured data means, this is the example. Let's say you have a kind of, if you join the Dombo system level, you will learn about the uh, web programming language. And this is one of example using the JSON. It is the JavaScript object notation. So if you have this kind of structured data, it's easy to mine the data. But now it's getting popular to get the data from the multimedia. So let's say you know the house, okay, apartment, and then you will see some text whether the house has been sold or not, or the house now is going to be rent or not. So this kind of multimedia is more complicated because you need to combine with the picture and text. If we have free text, the free text means like the article in the news, or article in the blog, okay, or article in the any website. So you need to analyze what is the meaning of this article. So there are many mining methods, like we can classify the news into some categories. Maybe the news is about sports, the news is about politics, the news is about economy. So how they can distinguish those news? So they calculate with some methods in the free text. Or the hypertext. The hypertext is also referred to the web because this is the HTML, hypertext markup language. So for every text, there will be some definition. What is this definition of the text? So this is also related with the web. So when we deal with the text data, we also have the text database. And we call this is the IR, text database, and IR. IR means the information retrieval. Text database or document database, it is a large collection of documents from various sources. You can have news articles, research paper. Research paper means like non-moon. Books, digital libraries, email, web pages, or library database, and etc. And data store is usually semi-structured. Semi-structured means one kind of data has the structure, but the other data is not in the structure. Traditional information retrieval techniques become inadequate for the increasingly vast amounts of text data. So the traditional information retrieval yeah, because it is traditional. Nowadays, there are many there are many news portals, there are many digital libraries, and you receive a lot of emails. So the traditional techniques does not fit. It's not suitable. So there are some researchers in the domain of the information retrieval, a field developed in parallel with the database systems. So the information is organized into a large number of documents. So we can say like if we have a news, so we can put it into one document. And if we have another news, we can put also this one into another document, and so on. The information retrieval problem means locating the relevant documents based on the user input, such as keyword or examples document. So I would like to discuss the information retrieval. The information retrieval is the typical IR system. It is in the online library catalogs, or it is the online document management system. So it is different with the common database system. Some DB problems are not present in the IR. IR is the information retrieval. For example, updating. So update, usually it does not appear in the IR. We have the text, so we just want to collect the text. Transaction management. This is the problem in the DB, but it does not appear in the IR. Complex objects. So if you learn database, in the database, you will deal with the complex object. Maybe there's a table. The table contains of name, and then maybe student ID, and then it contains photo. So the name is in the text, student ID is in the text, but photo, it is the format of image. So yeah, that kind of complex object is not in the IR. So some IR problems are not addressed well in the DBMS. For example, unstructured documents. So when you write your thesis or when you write your notebook, there is no such structure. Approximate search using keywords. So if you go to the library, you want to find some books, usually you will put the keywords. What is the keywords? Okay, I want to find Java, or I want to find Python book, or I want to find machine learning book. Okay. So it depends on the keyword and the relevance. So if you go to Google, for example, when you search something about machine learning, then it will show only the relevance document for you. But maybe your search different with my search result. We call this is the basic methods for the text retrieval. We have the precision and we have the recall. Precision means the percentage of retrieved documents that are in fact relevant to the query. So we call this is the correct response. Let's say I have all documents, relevant documents, and we have the retrieve document. If we have this relevant and retrieve, so we want to measure this one. The relevant and the retrieve, the number of document that is relevant and retrieved divided by retrieve. It is the precision. Recall is the percentage of the document that are relevant to the query and were in fact retrieved. So if it is recall, it is the number of relevant and retrieved, the number of relevant and retrieved divided by the number of relevant. Okay. So the difference is only the divisor. It is divided by number of retrieved. This is divided by the number of relevant documents. So for example, an IR system returns 8 relevant documents. We have 8 relevant documents and 10 irrelevant documents. In total, there are 20 relevant documents in the collection. So what is the precision of the system on this search? And what is the recall? So we have this one. The IR system returns 8 relevant documents. The meaning by return means it is the retrieve and relevant. And there are 10 which is irrelevant. Then we need to check how many documents do we have? We have 20 relevant documents. So let's get back to this formula. We want to know the precision. The precision means the number of the relevant document that has been retrieved divided by the total number that you retrieve. So here we got 8 retrieved and relevant documents. 10 of them are irrelevant. And we know that this one is the total. So the precision will be 8 divided by 80. 18 is the number of retrieved documents. What about recall? Recall is the same. We want to know how many retrieved and relevant documents, which is 8, and how many is the relevant document. The relevant document we have 20. Then we divide with 20. So we can say that the information retrieval, we have the precision is 0.44 and we have the recall, this is 0.4. So if the precision is high or it is near 1, then it is good. If it is near by 0, then it is bad. Now let's see another example, Q2. For a given query, there are 16 relevant documents in the collection. 16 relevant documents. The precision for a query is 0.4. And the recall for the query is 0.5. 25. So how many documents are in the result set? We need to check based on the formula. The precision is 0.4. The recall is 0.25. Okay. And then we know that the precision is the relevant and retrieve divided by the retrieve, the total retrieve documents. And the relevant divided by the relevant documents, it is the recall. So we can say the 0.25, it is the result from the relevant plus retrieve divided by 16. So we have the number of relevant and retrieve is 4 documents. If we have the 4 documents in this case, then we can input 4 into this and we can get the number of documents, which is 10. So the result set or the retrieve, the total retrieve from this IR, we have 10 documents in the result set. Yeah, this is the example how we can measure the precision and recall for the information retrieval. Keyword. So a document is represented by a string, and we can identify by a set of keywords. So if you look at the notebook, you will see they will give you keywords. So let me show you. If you go to the let's say I have the keyword, okay, machine learning. So every document which has the keyword machine learning will be shown here. Let's say I would like to see this one. So they will give the keyword. So you can see, okay, this paper give you the keyword machine learning. So we get this result. So this is the keyword-based retrieval. The queries may use expression of the keywords. So for example, I want to check the car and repair shop. Or I want to check tea or coffee. Or I want to check the DBMS but not Oracle. So we have the queries and the retrieval should consider the synonym. Synonym means if I want to check repair, the synonym of repair is maintenance. Then we need to check whether there are some keywords of the maintenance or not. In our case, machine learning is a new keyword, but sometimes in the paper they use data mining, or sometimes they refer to like data analysis. So there are the similar keywords, or we call this is the synonym. So this is the major difficulties of the model. The synonymy. A keyword T does not appear anywhere in the document, even though the document is closely related to the T. For example, data mining. So if you look at this paper, when I search this paper, they call machine learning. But actually, if you look at the details, some of them are related with like the deep learning, and they are related, with the data mining. So the keyword data mining is not here, but the content is about the data mining. So that's the major difficulties. And we can have polysemy. Poly, do you know poly? Poly means many. Okay, one word can represent many meanings. The same keyword may mean different things in different contexts. For example, mining. So in Korea, mining, I don't know the Korean word. But if you look at the mining, when you search on the internet, for example, I want to have coal mining. So it is related with the mining like this one. But if you deal with the data mining, it's related with the techniques or the algorithms. We have the same mining, but it refers to different meaning. So this is the polysemy problem. Again, we can check the similarity. How we can check the similarity in the text database? So we can find the similar documents based on the set of common keywords. So if the keywords are similar or if the keywords are the same, then we can say that they are similar. And the answer should be based on the degree of relevance based on the nearness of the keywords. For example, the relative frequency of the keywords. Some of the basic techniques is using the stop list. Stop list means some of the words that are deemed irrelevant, even though they may appear frequently. What does it mean? Irrelevant. In English, you can see there are many words like the, of, for, with, etc. So those words actually are not that important because it is just something to represent whether it is singular, or plural. The, it is to represent about something. So there is no meaning because this is irrelevant. So we can remove it. Stop list may vary when document set varies. So it depends on the documents. If it is news, maybe you can remove all of them. But if it is the scientific document, for example, for the notebook, some of them might be important. So there are some ways to measure the similarity. We call it word stamp. In the text, the word stamp means several words are small syntactic variants of each other since they share a common word stamp. Stamp means we want to change the word into the original. Drug, for example, you go to the drugstore. Drug, it can be noun. singular. But drug can be plural. Or drug, it can be a verb. So when we stem the word, so there will be some small syntactic variants. They have the common word stem. So like drug, drugs and drug, they have different meaning, but they will have the same stem. So the result of the stemming, they will be drug. So this is the original word. So something like in the Korean, you have the mokta. Mokta is the original word of it. Mogoso. Well, and then you will have mogoyu. But the original word is mokta. So in English, we also have that kind of words. You can have drug, you can have drugs, you can have drug in the verb, but all terms we have one word for the word stem, which is drug. So we can make a kind of term frequency table. Oh, sorry, maybe I will. This is one of the algorithm, Porter stemming algorithm. Okay. So this is one of the very complicated one. For example, I have motivational. So if we remove the tional, it means we have the keyword motivate. Motivational. This is the long word. But if we want to stem it with the Porter stemming algorithm, the original word will be motivate. Emotional. The emotional is the long word, and then with the Porter stemming algorithm, we can make the reduction into the original word, which is emotion, and so on. So this kind of mechanism, it is necessary to find the original word, and then after we have this original word, we can measure the similarity. Because it is impossible to measure the similarity between emotional, or if you have another keyword, emotionally, which is almost similar. So we need to make it stem. So the keyword will be based on the same stem word. That's the word. That's the meaning by the word stem. We need to make the original word. So every different word will give you the same word. And then we will make the frequency table. It means how many words appear in the document. So usually we use the ratio instead of the absolute number. The ratio means if we have like 3, 5, and then for example we have 2, then we will use the ratio. So this is the total is 10, then it is 0.3, this is 0.5, this is 0.2. So we will use the ratio instead of this original integer number. So we can calculate the similarity. The similarity means the measure of the closeness of the document or the query. So if you still remember the cosine distance. The cosine distance is the distance measure that you learned before the mid exam. So one of the common approach for this one is the TF idea. Term frequency, inverse data frequency. TF means term frequency. IDF means inverse data frequency. It is long definition, but I can just make it short like this one. The term frequency means I want to know the number of frequency of that word divided by the total number of keywords in that document. IDF means the inverse data frequency. It is the log function between the number of the document divided by the DFT. So DFT is the number of documents containing the word. And then we will make the weight, which is the TF multiplied by the log. TF is this one, then multiplied by the IDF. Maybe I will just show you one example. I have two sentences. The sentence one is the car is driven on the road. And the sentence two is the truck is driven on the highway. So we will check the, here we have one. Car, we have one. Truck, it is 0. Is 1. Driven, it is 1. On, it is 1. The, it is also 1. Road is 1. Highway is 0. So why it is different? Because this one contains uppercase, this one small. So we can make it as different. But actually, yeah, we need to make like the common words, make it in the small. But let's assume this is different. So the A will be calculated and B will be calculated. So after we have this one, yeah, we can make the TF. What is the TF? We have the 1 for the divided by the total number of the words. So we have 1, 2, 3, 4, 5, 6, 7. We divide with 7 for the A. And what is the TFB? Same. For the, we have 1 divided by 7. And then we have the car. Car is 1 divided by 7. There are 7 words here. And it is 0 because we have no word car in the second sentence. So the idea, it is log 2. We have 2 documents or we have 2 sentences and 2 of them contain the. Here is log 2 divided by 1. Why? Because among the 2 documents, we have only one that contains car. This one is also 1. Among the 2 documents, only one that contains from. So we can get this. So the result will be A. A is the 1.1 divided by 7 multiplied by 0. So it is 0. This is 1 divided by 7 multiplied by 0. It is 0. In this case, 1 divided by 7 multiplied by 0.3. Then the result is 0.042. 0 multiplied by 0.3, it is 0. So this is the result of the TF idea. What does it mean? So the higher number of the ITF means this is the distinct value. Distinct value. If the word is different, then it will give you more certainty to classify the document. So if the word is the same, like this one, the, both of them contain the, then it's zero, no meaning. But if the word one, if the sentence one contains card and the second contains truck, okay, you can see the value. The sentence one contains road, and the first one contains road, and the second contains highway. So you will see there are some numbers. So they are distinct. Then you can say that those two sentences, they are different in terms of the word car and truck and the road and highway. The remaining words are the same. So this is how you can classify the documents. If they contain the similar word like the, driven, then it may be in the same category. But if they have different keywords like truck, road, and highway, then they may have in the different categories. Oh, okay. Then let's have a break. Yeah, I will continue after the break.